Hi there, Mr. Sutton here, bringing you the IM Pre-Honors 4-6 lesson on quadratic inequalities. In this one, we're going to be learning to graph quadratic inequalities on the x and y axis.
Hello there, Mr. Sutton here, bringing you this lesson on quadratic inequalities. In this one, we are going to be graphing quadratic inequalities. For your warm-up, here's some review of two-dimensional inequalities. See if you can fill in these blanks, and then, based on what you fill in, see if you can graph this inequality. All right, let's see how that went for you. So we have equals inequalities like greater than or equal to or less than or equal to, and those are going to give us, when we graph them out, a solid line and solid dots, so that's solid if you have equals. In contrast, if you don't have equals, if you have just greater than or strictly less than, then you would have a dashed line with open dots. And if you have y less than some equation, then that would be shading below. You'd be shading the y values lower than that. And if you have y greater than, then you have to shade above. So with that in mind, let's tackle this one right here. So this is basically a line, but we have to shade one side or the other. So the y-intercept of the line, which is in slope-intercept form, that's going to be this 1 right here. So we're going to put a dot on 1 on the y-axis. Now, because the inequality does not have an equals, that's going to be an open dot. So open dot right here. And then we have a slope of 1 as well. So up 1, right 1. So we go up 1, right 1 from the y-intercept, and that's another open dot. And to go through open dots, we're going to have a dashed line, like so. Now we have to pick one side or the other to shade. Since this is y greater than, we're going to shade all the y values that are above this line right here. So this stuff up here. Now what you can do is you can test a point to check to see if you shaded the correct side. For example, 0, 0 is usually a pretty easy one to test. So how you do this is you just plug this point into the inequality and see if it comes out true or not. So we have the y value 0. Let me plug that in for this y right here. And we have the x value 0, so I'll write greater than 0 plus 1. But I'm going to put a question mark there because I'm not sure if it's true or not. So is 0 greater than 1? Well, no, 0 is not bigger than 1. This is false. What that means is that we would not shade the region that had 0, 0 in it. And if you look at your graph, 0, 0 is right here. It's the origin, and we did not shade that, so we're probably on the right track. So for the rest of this lesson, we're going to bring together two different ideas. We're going to do that inequality graphing in two dimensions like you did on the warm-up, but we're just going to apply that to parabolas, which we've already spent a lesson graphing. So let's go ahead and graph this one out, and we'll do this one together. So this is in standard form. All the ones you're going to see in this lesson are standard form, although everything we're doing applies even if you have different forms. So to get the vertex out of this, that's what I'm going to start with here. I need negative b over 2a. So that's going to be negative 2, the coefficient of x, over 2 times we have a negative 1 for the a value here. So this is 2 over negative 2, which is negative 1. And I'm going to plug that back in to get a y value. Now when I plug it in, I'm going to write equals here instead of less than, because I'm trying to get the exact value of y that goes with this x value. So I'm going to write y equals negative 1 squared minus 2 times negative 1. And let's see here. This is negative 1 plus 2, which is 1. So our vertex is at negative 1 comma 1. And I'm going to go ahead and graph that out. Now, again, you have to look to see when you start graphing things, do you have the equals or no equals? And in this one, just like the warm-up, there's no equals. So I'm again going to use an open dot, this time on negative 1 comma positive 1. So negative 1, 1, that's right here, open dot right there. And just like in the other lesson when I was graphing these, I use the y-intercept usually to get another point. Now, there's no y-intercept here. There's a plus 0, I guess. So that means we have a y-intercept of 0. So that's going to be right here. And then I'll use symmetry to get another point on the other side of this axis of symmetry that goes through the vertex. So we have another point right here at negative 2 comma 0. And now I can draw the parabola, a dashed line through open dots. Now I have to decide, am I shading above or below that parabola? So I look back here at my inequality. I have y less than. That means I'm shading lower than the parabola that I just drew. So that's all this stuff down here. And we're done. Here's another example. This one you can pause the video and try it out on your own. All right, so just like before, let me find the vertex. So that's negative b over 2a. So in this case, negative 2. Negative 2 is our b value. And we're doing 2 times positive 1 this time around. So that's 2 over 2, which is just 1. Plugging 1 back into the expression here, we've got 1 squared minus 2 times 1 plus 3. That'll give me the y value of my vertex. So that's going to be 1 minus 2, which is negative 1, plus 3 gives us positive 2. So we have a vertex then of 1, 2. And this time around, when I graph this out, I notice that I have equals in my inequality, less than or equals. So I'm going to use a solid dot and a solid line. So we've got 1, 2 for the vertex, solid dot right there. And for the y-intercept this time around, that's this constant 3 right here. So 0, 3 is our y-intercept, and that is up here, another solid dot. And our axis of symmetry is on x equals 1, so we just reflect over that line to get a symmetrical spot with that y-intercept. Draw the solid line through these solid dots now for the parabola. And since it says y is less than, I'm going to shade below this parabola. So that's all this outside stuff here. But really the important piece is that this is below the line. We don't really think about it in terms of inside or outside. It's just above or below that we care about. Having fun yet? We'll do one more. Pause the video. Give this one a shot. All right, so negative b over 2a is going to give us negative 4 over 2 times 1/2. So this is a little different because we have a coefficient other than 1 or negative 1 for a. So this is negative 4 over, let's see, 2 times 1/2 is just 1. So this is negative 4. Plugging that back in, we've got 1/2 times negative 4 squared plus 4 times negative 4 plus 2. Negative 4 squared is 16. Half of that is 8. This is negative 16 over here, so 8 minus 16, giving me negative 8. And negative 8 plus this 2 finally, that's going to be negative 6. So negative 4, negative 6 is our vertex. No equals, so we use open dots again. So we were at, let's see, negative 4, negative 6 is down here. And now the y-intercept in this one is just this 2 constant right here, so 0, 2. That is all the way up here. That's a long distance. And then I need to get my symmetrical point. I'm 4 away, 4 to the right of the axis of symmetry at that y-intercept. So I need to go 4 to the left at the same height, right there. And let me get my dashed parabola through those open dots. And now y greater than says I'm going to be shading above this parabola, so that's up here. So that'll do it for this one. Till next time, Mr. Sutton signing off.